Okay, so what I'm going to walk you through are some of the new updates that we have in the Serac software for us to be able to do models, splints, and custom impression trays directly from the Serac chairside software. So with this updated JSON file, which is a JavaScript file, you do not need to interface regularly with Densify Sirona InLab. That being said, in order to be able to interface with in-lab devices on your Serac software, you will have to install Serac InLab 22.1, Serac InLab Splint, Serac InLab Model, and if you would like to do partial frameworks, you could also install the partial framework module. There is also what's called a JSON or JavaScript file for you to be able to run that software on your Serac PrimeScan. This does not work on OmniCams that we have currently in the US Army, just because the PC and chipset version are different, and this JSON file will not allow you to do that install. That being said, this should be a pretty good workaround for everybody to send an acceptable model to the Army Dental Lab to make their life easy and our life easy, so we get really nice looking restorations. I'm going to go ahead and open up a test file and kind of show you what the easiest way to do this is. We don't want to spend a lot of time designing our restoration because let's say you just don't feel comfortable essentially making an anterior restoration. Maybe it's just based on your own comfort level, the materials you have in house. There's a lot of different reasons. So what we're going to do is we're going to go ahead and we're going to load this up. So once we install the JSON file, which I will give everybody's IT department a instruction on how to do this, you'll see a couple different indications pop up. You have crown, you have bridge, you have implant, and you have implant guide. Now what you're going to see pop up are a few different things. You're going to see we have a model, we have a tray, and we have a splint on there. Okay, so this is pretty cool. So pretty much everything that you need to do as a general dentist is right here on this main tab. For this one, we're going to be doing a crown on tooth number 8. We're going to be milling it out of tetric CAD, or grinding it, I should say, because it's not a millable material. It's a grinding material. It uses diamonds. We're going to go ahead and select tooth number 8. Now when you select tooth number 8, you're going to see that a couple options disappear. Our custom tray and our splint disappear. But you can see model is still open. The reason I want this is I want to be able to send the Army Dental Lab a model for me to actually go ahead and fabricate a final restoration. But I want to send it to them as an STL file so it's easy to send, and it can work in any software that they choose to use, whether it's ExoCAD, 3Shape, or even bring it back into InLab. So we're going to go ahead and select next. We want to make sure that we have a working model selected, because a working model means that we're going to ditch it. And then we want to make sure that we have our tooth selected. We'll go ahead to model. And I always go to my edit model screen to make sure that both my upper and lower model appear to be trimmed. These are trimmed. If they're not, you can go ahead, double left click, and trim some of this excess stuff out the way that you don't want. And that's just going to make our life easier later on down the road, trust me. So now we're going to go ahead to our model axis screen, and we're going to make sure that our maxillary dental midline is parallel with mid-sagittal plane. Some people prefer to take this and move this to be parallel with the maxillary mid-sagittal plane. I like to have it with my dental midline because typically if it's a single tooth, I'm not worried about my mid-sagittal plane other than being parallel to it, not necessarily coincident with it. So we're going to click OK. We're going to go ahead and we're going to draw our margin. Now for this, I'm going to go ahead and delete my margin, and I'm going to show you kind of how I walk through this step real time. So we're going to double left click to start, single left click to save my progress. And I don't get too freaked out if it starts to kind of jump off my model, because I'll go back and I'll fix those couple of areas. So we're going to come over here. There we go. double left click to start, single left click to move, and then double left click to end. So double left click to start, single left click to save my progress, double left click to end. Now I followed a very similar workflow with the older Serac software on this case. So if you're interested to see how this case actually turned out, I have a PowerPoint presentation that I put on my private YouTube channel that you can just search my name and look it up. And it was actually the presentation I gave at DS World on how we manage anterior aesthetics with Serac. And I used this actual case. So overall, this looks like a pretty good margin line to me. So the next thing we're going to do is we're going to go ahead and set our insertion axis. So our insertion axis, typically you want to see a little bit of our contacts on either side. We want to see minimal undercut. We'll click OK. And now we're going to go to design. Okay. So the reason we're going to do design first is this. I want to be kind of combining my workflows so I'm not wasting time and doing work after work. So what I'm going to do is go to my restoration parameters, and I'm going to make sure that we have this changed. Typically, for a Emax anterior restoration, I'm looking at a minimal occlusal thickness of about 1 millimeter. You can take it down to 800 if you really want to. Manufacturer typically recommend around 800, and then the anterior, depending on what your substrate is, this can change. They say 500 microns if you're bonded to enamel for a veneer. I'll typically go around 700 microns if I have enamel and dentin and I have a good tooth substrate and no major parafunctions. So we're going to click OK. Now what I'm going to do next is we're going to go ahead and just do some basic adjustment to what's called my position of the crown. Nothing too crazy. Okay. So overall, I'm pretty happy with that appearance. Let me bring this back just a tiny bit. Perfect. Overall, looks pretty good. I'm going to tell the computer I don't want you to use constrained adoption, so I'm going to make sure this box is completely unchecked, and we'll click Edit Restoration. You notice my restoration didn't change. Go ahead and hit the Recalculate button, and your restoration will now change. All right. Overall, it's pretty darn good for a provisional restoration, but we want to make a couple changes. So we're going to come over here, try to get rid of some of this minimal thickness that we have. We're going to come over here, make this a little bit thicker. Okay. And as I adjust my occlusion further, I'm going to make the size of the tool smaller. That's making the adjustment. And overall, I'm happy with how that turned out. Now what we're going to do here is we're going to continue to close this diastema from the lingual. So we're going to take this incisal edge, bring this up. Bring that back. Last thing we're going to do is flip the model upside down. We want to make sure we only have green showing through. That's going to be our proximal contact. So we'll use the smooth tool until we just have green. So we just have green. This red right here is just showing that it's touching the soft tissue. This doesn't really concern me too much. So overall, pretty happy with this restoration. Maybe it's a little long, so we'll go ahead and take our two-directional shape tool, bring it down just a little bit. All right, and overall, for all intents and purposes for provisional restoration, pretty happy with this provisional. Okay, not a lot of time spent, and we'll go ahead and we'll manufacture this restoration. So we're going to go ahead and click Start. If we're using an MCXL, we're going to keep it at the offset at 0 on an anterior tooth. If we're using the prime mill eliminates this tool and you don't see it anymore. So if we go to the prime mill, you'll notice that our offset completely goes away. All right, so let's pretend that we started milling this. Okay, we're going to have about 12 minutes while it's milling. So let's see if we can get our model work done in 12 minutes. So now that the restoration is going through the manufacturing phase, we'll go back and click on Model. We'll come over here to View Model, and we'll go ahead and click Start Design App. Okay. Okay, so now the correct design software app has opened up, which is CERAC in-lab model. And we're going to go ahead and click on Clean Model, and we're going to click on Apply. I usually generally have my thickness set to 3 millimeters and my base extension set to 0, and I have my upper and lower model looking the same. Now the reason it was so important for us to trim and edit our models in the chairside software is it makes our life a lot easier here by giving us a really nice flat base. So now we have a great solid model to work with to send to the Army Dental Lab. We'll go ahead and click Next. And now what we want to make sure is if we were to look on this STL model, my margin, if it wasn't marked with this red line, would totally disappear. So what we're going to do is click Create Stump and make sure that we only have the ditch selected. If we hit Create Stump, it's going to create an actual die, which we don't want to do. So we're going to go ahead and create our ditch, and we want the smallest possible ditch, which is 0.5 millimeters. We're going to click Apply. Now what that did is that applied a nice ditch all the way around my model for the Army Dental Lab. So that way, whatever software they use, they should be able to see a nice clear representation of my margin for this tooth. Now we're almost done at this point. We're going to click Finalize. We're going to come over here. We're going to go ahead and add a text label. We'll add A1 Emax. And we'll make sure it's a recessed version. So we'll click right there. And that's done. Now we're going to go to Export. Okay, once we click the export screen, you can see what we have here now. We went ahead and we have our ditched STL model of the top, our solid STL model of the bottom, and also our top model is solid as well. So if you're going to submit these to the Army Dental Lab as solid models, it's going to require them an additional step where they're going to have to open up the mesh framework of these models. I'll show you kind of what they're going to have to do when it gets to the Army Dental Lab, but you yourself don't have to do this step. But what you need to give them is a couple pieces of information to make it easier. First, you need to click on Single File. What that's going to do is that's going to export a buccal bite image of the top and the bottom teeth fixed together as a single file. That's going to allow them to import an adequate buccal bite registration. So for that, you're going to go ahead and click STL. We're going to save this to desktop as buccal bite and click Save. The next thing you want to do is put each file individually. So you're going to select an upper and a lower, and so you're going to uncheck this single file box. And when you click Export as STL, we'll put number 8 STL, number 8 model. Okay? It's going to automatically save an upper and a lower to the desktop for us. So that is all you need to do to submit to the Army Dental Lab and attach those 3 files to your LabTrack Connect folder. Now I'm going to open up Mesh Mixer next to show you how they're going to open the files and make what's called an open mesh framework once it gets there. If you wanted to do this additional step for them, you can, but it's not a requirement. Okay, so now I've got Mesh Mixer open, and I'm going to show you essentially how they're going to take the models that you sent them and open them back up. Most digital design softwares do not like dealing with they definitely don't like dealing with solid models. It messes up with the design mode of the software. So here's what we're going to do. I only want to look at one model at a time so I don't confuse myself. So I go to this object browser and I turn off the other 2 models, so I'm only looking at my top model. What the Army Dental Lab is going to have to do is go into this edit function and go into plane cut. And with a simple left click and drag, and then they clicked no fill, and click accept, we now have an open STL file for them to bring into their software. all they have to do from there is click export, overwrite this as an STL binary format, click save, and we're good to go. We'll turn that one off. We'll go to our lower model next. We'll go into our plane cut function. If it plane cuts it the wrong way, just start your left click from the other side. And now we look good. We'll go ahead and we will do no fill. Now we have an open STL file. We'll click accept, file, export, lower model, save, replace. Now we'll do the last one, which is our buckle bite. Now for this, we'll do our plane cut twice. So we'll go ahead here, we'll go plane cut. We'll plane cut once here. Accept. Plane cut here. No fill, accept. File, export, buckle bite. And now the reason for this is you can see this is an open file now, which makes it a lot easier for any digital design software to recognize it. And also doing this, it should remove any sort of like metadata that the company's attached to that STL file. And this should make it just like any other STL file that you would typically get from any sort of STL generating software. But that is it. That took us less than 10 minutes. Our crown is out of the mill, and now we're ready to submit our provisional restoration. Hopefully it's a pretty easy tutorial, and in order to be able to do this, like I said, you're going to have the software version 5.2.3 for your chair side. You'll have to have your InLab 22.1 software installed, along with your model and your splint modules on your PrimeScan. And then your IT department will also have two separate JSON files or JavaScript files that they're going to have to put into the hidden folders for program data, which I will send them a tutorial on how to do that. And you will have this ability to be able to send a ditched STL model off to the Army Dental Lab in no time at all. Thanks so much for watching.